When you look at the smartphone in your hand or think about the sensors in modern cars, have you ever really stopped to think about how they're made? For a long time, the story's been pretty much the same. Huge factories, tons of energy, and unfortunately, a giant pile of e-waste. Well, that whole story is about to get a major rewrite. We're going to dive into a revolution that's totally changing how we build our electronic world. But let's start with something really practical. Picture a self-driving car on a miserable, rainy, muddy day. Its eyes, all those cameras and sensors, are getting caked in grime. How can it possibly see? Now, what if the surface of that sensor could just shrug off all that dirt and water instantly? That's not science fiction. It's actually the key to making all this automated tech safer and way more reliable. So, to make that happen, scientists over at Durham University had to solve a really fundamental problem. How do you get tiny drops of liquid to move exactly where you want them on a surface, but without any moving parts? No little wipers, no pumps, nothing. The answer, it turns out, is to manipulate the physics of the surface itself. The magic behind this is a technology called electrowetting. It sounds complex, but the idea is brilliant. By applying a tiny electric field, you can make a surface flip a switch. It goes from hating water, hydrophobic, to loving water, hydrophobic. By controlling that, you can literally pull or push a droplet wherever you want. It's like having a remote control for tiny drops of water. The actual surface is built up in these 4 layers, kind of like a sandwich. First, you have the base, the substrate, which can be glass or even flexible plastic. Then you lay down the electrode patterns. That's the real engine here. An insulating layer goes on top to protect them, and the whole thing is finished with a super slippery, water-hating topcoat that helps the drops glide around. It's just a really elegant, solid-state solution. And the result of all this? It's seriously impressive. You only need about 30 volts, and the system can move not just water, but all kinds of gunk. They took it out for road tests, and it cleared everything: rain, mud, dirt, even sand, keeping a camera's view totally clear. It's a powerful and, more importantly, a practical fix. Okay, so we can move droplets around to keep things clean. That's awesome. But what about the electronics that are actually controlling this whole process? Well, that brings us to the second huge breakthrough. Is it possible to create the brains for these devices in a way that's cheaper, more flexible, and a whole lot better for the planet? I mean, just look at the difference here. The old way of making electronics is an energy hog. It needs these giant vacuum chambers and creates so much e-waste from those stiff silicon wafers. This new method, coming out of Duke University, is more like using a super advanced inkjet printer. It's low energy, uses fully recyclable carbon-based inks, and you can print on flexible stuff, even paper. The difference is just night and day. And the tech that makes this possible is called capillary flow printing. It actually uses the same basic idea that makes a paper towel soak up a spell, that capillary action. It uses it to pull these incredibly precise amounts of carbon-based ink out of a microscopic needle. And that precision, getting down to the sub-micrometer scale, is the secret to printing transistors that are both tiny and really powerful. So just how powerful are we talking? You might be thinking, sure, it's printable, but is it any good? Oh yeah. These things have already shown they're strong enough to control the pixels in an LCD display. And they're getting really, really close to what you'd need for the beautiful OLED screens in our best smartphones. This isn't just a lab curiosity. This tech is ready for the big leagues. So we have self-cleaning surfaces, we have printable, recyclable circuits. Awesome. But a cool prototype in a lab is one thing. How do you actually scale that up to make millions or even billions of devices? How do you make this revolution affordable for everybody? The answer is something called roll-to-roll, or R2R, manufacturing. So forget making one little chip at a time. Instead, picture these massive, continuous rolls of plastic or foil just speeding through a printer that lays down electronic circuits. It's almost exactly like how newspapers have been printed for a century, but for electronics. It's a high-speed, low-cost game changer. And the scale of this whole shift is just immense. The market for all these flexible devices made with roll-to-roll tech, it's projected to be worth a whopping $77.6 billion by 2030. This isn't some niche market. This is the future of how we make things. Yeah, and this chart really puts it into perspective. Look at that jump. From $38.5 billion in 2024, the market is set to more than double in just 6 years.
That kind of explosive growth tells you everything you need to know. This is a major industrial pivot happening right now.
So what happens when you put all these different pieces together? You get self-cleaning surfaces, powered by high-performance recyclable circuits that are all produced at a massive scale using low-cost, low-energy printing. See, it's not just about making a better gadget. It's a whole new way of thinking. And this is why it really matters to all of us. This combination makes so much possible. We're talking about smarter, safer cars, cheaper, flexible solar panels you could unroll like a carpet, the foldable phones of the future, and even advanced medical sensors you could wear like a Band-Aid. It just makes amazing technology more accessible, more durable, and so much more sustainable.
You know, Aaron Franklin from Duke University really hit the nail on the head. He said, if we want to seriously increase US-based manufacturing, we need transformational technologies. And he's absolutely right. This isn't just about innovation. It's about transforming economies and our environment.
So let's just sum it all up. We've looked at 3 totally separate breakthroughs, right? In surface physics, in printable circuits, and in mass manufacturing. But when they come together, they merge into this one huge revolution that promises to make our electronics smarter, more sustainable, and ultimately available to everyone. And that really leaves us with one last massive question to think about. For hundreds of years, the printing press made information accessible to everyone. Now we're on the verge of being able to print intelligence itself. So if electronics can be printed as easily and cheaply as paper, what are we as a society going to write on the future?